For centuries, people have looked up at the night sky believing it was calm and almost unchanging. The stars appeared fixed, the constellations remained familiar, and only an occasional comet or meteor hinted that space was alive with motion. But modern astronomy has revealed a very different reality. The universe is constantly changing, and a new observatory is allowing scientists to witness that change like never before. High in the Chilean Andes, where dry air and dark skies create ideal conditions for astronomy, the Vera Rubin Observatory has begun an ambitious mission unlike any previous telescope. Rather than focusing on one distant galaxy or one nearby planet, its goal is much broader. It is designed to observe enormous portions of the sky repeatedly, building a continuous record of how the universe evolves over time. During its first observations, the observatory immediately demonstrated its extraordinary capabilities. Within a remarkably short period, astronomers identified thousands of previously unknown asteroids, including numerous objects passing through the inner regions of our solar system. None of these newly detected bodies posed an immediate threat to Earth, but their discovery highlighted an important scientific reality. These objects were not newly created. They had always been there, quietly following their orbits around the Sun, escaping detection simply because previous surveys could not observe such large areas of the sky with the same speed and sensitivity. Rubin's observations showed that our own solar system still contains countless hidden objects waiting to be discovered. Space often appears empty when viewed with the naked eye, yet it is filled with constant activity. Asteroids travel through the main belt between Mars and Jupiter. Comets return from the distant outer solar system carrying ancient material preserved since the birth of the planets. Occasionally, visitors from other star systems briefly enter our cosmic neighborhood before disappearing back into interstellar space. Tracking all of these moving objects is an enormous challenge. Traditional telescopes usually observe relatively small sections of the sky, making it difficult to monitor everything at once. The Vera Rubin Observatory was designed specifically to overcome this limitation. Instead of staring at one target for hours, Rubin repeatedly scans vast regions of the southern sky. Each new image is automatically compared with earlier observations. Sophisticated software searches for anything that has moved, appeared, disappeared, brightened, or faded. This process allows astronomers to detect changes that would otherwise remain unnoticed. At the heart of the observatory is one of the most advanced astronomical cameras ever constructed. Containing approximately 3.2 billion pixels, it captures an enormous field of view in a single exposure. Every image records millions of stars, galaxies, and solar system objects simultaneously, providing an unprecedented amount of scientific information. Because the telescope repeatedly returns to the same areas, researchers can measure how celestial objects change over days, months, and eventually years. A stationary point of light is likely a distant star or galaxy. An object that slowly shifts position may be an asteroid or comet moving through our solar system. This ability to recognize motion automatically is one of Rubin's greatest scientific strengths. The observatory is effectively transforming astronomy from a collection of individual photographs into a continuous time-lapse movie of the universe. Every observation adds another frame, allowing scientists to watch cosmic events unfold instead of discovering them only after they have happened. The early asteroid discoveries are only the beginning. Over the coming years, Rubin is expected to detect millions of additional small bodies throughout the solar system. Each new discovery improves our understanding of planetary formation, orbital evolution, and the history of our cosmic neighborhood. More importantly, these observations strengthen planetary defense efforts by improving the catalog of near-Earth objects and helping scientists calculate their future paths with greater precision. The first observations from the Vera Rubin Observatory delivered a powerful reminder. The universe has never been still. The difference is that humanity finally possesses an instrument capable of watching its constant motion on an unprecedented scale. In many ways, these first discoveries are not the conclusion of a mission. They are only the beginning of an entirely new era of astronomical exploration. The Vera Rubin Observatory is designed to do far more than discover asteroids. While its early observations captured attention by revealing thousands of previously unknown objects, its true mission reaches much farther into the universe. Every image it records contains an enormous amount of scientific information, allowing researchers to study nearby planets, distant galaxies, and everything in between at the same time. A single observation may include an asteroid crossing the foreground, countless stars within the Milky Way, distant galaxies billions of light-years away, and a supernova exploding in a remote corner of the cosmos. Instead of focusing on one scientific target, Rubin observes the sky as a complete, living system where many different events happen simultaneously. One of its primary goals is to investigate what astronomers call the transient universe, objects and events that appear suddenly, change rapidly, and sometimes disappear forever. These include exploding stars, variable stars that pulse in brightness, black holes consuming nearby material, and rare cosmic events that last only a short time. Before Rubin, many of these temporary phenomena went unnoticed simply because telescopes happened to be looking somewhere else. Rubin changes that approach completely. By revisiting the same regions of the sky every few nights, it creates a continuous history of the changing universe. Scientists can compare new images with older ones almost instantly and identify even the smallest differences. This constant monitoring also helps researchers study some of astronomy's biggest mysteries. By observing billions of galaxies across enormous distances, Rubin will help scientists investigate the nature of dark matter, the invisible substance that shapes galaxies through gravity, and dark energy, the mysterious force responsible for the accelerating expansion of the universe. Closer to home, the observatory will produce one of the most detailed maps of the Milky Way ever created. By tracking the positions and movements of billions of stars, astronomers hope to uncover ancient stellar streams left behind by smaller galaxies that merged with our own billions of years ago. These discoveries will reveal how the Milky Way slowly grew into the galaxy we see today. Rubin is also expected to become one of humanity's most effective tools for finding rare interstellar visitors. Objects arriving from beyond our solar system spend only a limited time near the Sun before continuing their journeys through the galaxy. Detecting them early gives scientists valuable opportunities to study material that formed around distant stars, offering clues about planetary systems far beyond our own. Yet perhaps the greatest scientific opportunity lies in the unexpected. Throughout history, astronomy has repeatedly advanced because new instruments revealed phenomena no one had predicted. Pulsars, quasars, exoplanets, and fast radio bursts all surprised the scientific community when they were first discovered. Rubin may uncover entirely new categories of astronomical objects that current theories have never anticipated. Handling such discoveries requires enormous computing power. Every night, the observatory generates vast amounts of data that must be processed almost immediately. Advanced software automatically analyzes every image, measures object positions, detects movement, identifies brightness changes, and distributes alerts to astronomers worldwide within minutes. This rapid sharing of information allows other telescopes on Earth and in space to immediately investigate newly discovered events before they disappear. Together, observatories around the world will work as a connected scientific network, each contributing unique observations to build a more complete understanding of the universe. Over its planned 10-year survey, Rubin will create the most comprehensive time-lapse record of the southern sky ever assembled. Scientists will be able to watch stars evolve, galaxies interact, asteroids travel across the solar system, and countless cosmic events unfold over time. The Vera Rubin Observatory represents more than a powerful new telescope. It marks a fundamental shift in how humanity studies the cosmos. Instead of seeing the universe as a series of isolated images, we are beginning to observe it as a dynamic, ever-changing system filled with motion, transformation, and discovery. Its greatest achievement may not be one extraordinary observation, but millions of small discoveries that, together, reshape our understanding of the universe. Every moving asteroid, every changing star, every distant explosion, and every unexpected signal reminds us that the cosmos has always been alive with activity. For the first time in history, humanity has the ability to watch that story unfold almost in real time, and this is only the beginning.